Imagine this. In the very heart of space, where time and space intertwine in a dance of infinity, something emerges that could overturn our boldest ideas about the origin of the universe. The James Webb Telescope has peered farther than ever before, discovering a tiny yet astonishing object. What lies behind this cosmic mystery? Why do its properties defy conventional understanding? But this is only the beginning. In the distance looms something even deeper, hypotheses that could challenge the very existence and nature of our universe. Are you ready to embark on a journey beyond the known horizons, where scientific dogmas meet the secrets of the meta-universe? Subscribe and like to stay updated on the latest discoveries and bold ideas that are already reshaping our understanding of the cosmos. The James Webb Space Telescope has made a discovery that fundamentally changes our understanding of the early stages of the universe's evolution. Scientists have confirmed the existence of the galaxy MOM-Z14, whose light traveled to Earth for 13.5 billion years, meaning it formed only 280 million years after the Big Bang. This object, discovered as part of the Mirage or Miracle project, is now the most distant spectroscopically confirmed galaxy to date, surpassing all theoretical expectations that existed before the telescope's launch. The spectrum of this galaxy, recorded using the NIRSPEC instrument, revealed two key features indicating its age. First, there was a sharp drop in emission at a wavelength associated with hydrogen in the intergalactic medium. Second, 5 faint ultraviolet lines were identified. These unique fingerprints made it possible to precisely determine the redshift at Z equals 14.44, which corresponds to observing the universe when it was only about 2% of its current age. What features make MOM-Z14 unique and draw the attention of scientists? What mysteries of the early universe might the study of MOM-Z14 help unravel? The galaxy. MOM-Z14 shines 20 times brighter than typical galaxies of its era, despite its tiny size. Its diameter is about 150 parsecs, which is roughly 1,000 times smaller than that of the Milky Way. Studies of its emission have revealed intriguing features. The absence of dust signatures and a steep ultraviolet spectral slope point to a young generation of stars formed during a sudden burst of star formation. Over the past 5 million years, the star formation rate in this galaxy has increased tenfold. The chemical composition of its gas, rich in nitrogen but lacking in carbon and oxygen, resembles that of ancient globular clusters in our own galaxy. This suggests that MOM-Z14 may be a kind of cradle for supermassive stars, whose explosions enrich the surrounding environment with heavy elements. This discovery raises important questions for cosmology. The density of such bright galaxies at a redshift of about 14 is 100 times higher than predicted by existing models, indicating a need to revise current scenarios of structure formation in the early universe. One possible explanation could be an extremely high star formation efficiency in compact regions, or the influence of alternative forms of dark energy. Even more intriguing is the detection of partial ionization of intergalactic gas around MOM-Z14, identified through weak hydrogen absorption. If confirmed, this would challenge standard reionization models, which assumed a fully neutral medium during that epoch. What secrets does the early cosmos conceal? Will new theories be able to explain anomalies that cast doubt on the most fundamental laws of cosmology? The discovery of numerous ancient and luminous galaxies, such as MOM-Z14, poses a serious challenge to modern cosmological models. It was previously believed that such objects were extremely rare in the early universe and represented simple, undeveloped structures. However, new data suggests that star formation and complex chemical enrichment processes may have begun much earlier and proceeded far more intensely than previously thought. This perplexes scientists and forces a re-evaluation of established theories regarding the formation and evolution of galaxies, as well as the conditions that existed in the first few 100 million years after the Big Bang. The crisis in cosmology is not merely a matter of adjusting individual models, it challenges the very foundations of our understanding of the universe. The more such objects scientists discover, the clearer it becomes that new theoretical approaches are needed to explain the emergence and behavior of these anomalies. What could the discovery of a preferred direction of galaxy rotation mean for our understanding of the origin and structure of the universe? The James Webb Space Telescope has discovered that 2/3 of the 263 ancient galaxies it studied rotate clockwise. This unexpected finding, made as part of the JDS project, JWST Advanced Deep Extragalactic Survey, challenges the long-held assumption that the universe has no preferred direction. According to current cosmological models, the universe is isotropic, meaning it looks the same in every direction. Therefore, the number of galaxies rotating in opposite directions should be roughly equal. However, the observed predominance of one rotational direction may suggest the existence of a global axis, or an inherited spin dating back to the universe's birth. One possible explanation comes from black hole cosmology. This theory suggests that our universe might have formed inside a black hole within a larger parent universe. The idea was proposed by physicist Raj Pathria and mathematician Irwin Good, who hypothesized that the event horizon of such a black hole corresponds to the boundary of our observable universe. This concept is also supported by Polish physicist Nikodem Popławski from the University of New Haven. He argues that matter falling into a black hole doesn't necessarily compress into a singularity, but may instead bounce and expand, creating a new universe. According to him, such a process could have triggered the Big Bang. If the parent black hole had angular momentum, it could have been transferred to our universe, causing the observed asymmetry in galaxy rotation. This, he says, is the most straightforward explanation. An alternative hypothesis proposes that the differences in brightness between galaxies rotating in opposite directions could be due to the Doppler effect, caused by Earth's motion around the center of the Milky Way. This movement might distort our perception, making certain galaxies more visible than others. Scientists continue to analyze the data collected by the James Webb Space Telescope in search of further evidence to support one of the existing theories. What secrets of the early universe might the Nancy Grace Roman Space Telescope reveal? Secrets even James Webb could not see. NASA's new space telescope, the Nancy Grace Roman, which is being prepared for launch, promises to become the key to unlocking many cosmic mysteries and rethinking our fundamental understanding of the universe. Recently, its main component successfully passed rigorous thermal testing, confirming its ability to operate in the extreme conditions of space, from scorching sunlight to the icy vacuum. This marks an important milestone on the path to launch, scheduled for May 2027, though the team hopes to complete preparations by the fall of 2026. Once the solar panels are installed and final assembly is complete, the spacecraft will head into space to provide scientists with new data about the early universe and test bold hypotheses that are currently challenging existing cosmological models. With the help of the Nancy Grace Roman telescope, researchers will be able to study the origin and evolution of galaxies in greater detail, investigate the nature of dark energy, and even search for exoplanets, areas where there is already a growing need to rethink scientific perspectives. This telescope will open the door to a new era of discoveries that may fundamentally transform our understanding of the structure of the cosmos and the history of its evolution. Follow along with the preparation and launch. The future of astronomy and cosmology promises to be truly thrilling. Subscribe to the channel and don't miss the latest news and exclusive content on the universe's grand discoveries.